In this video, I'll be explaining question 8 of homework 7. So we are given that Poisson process is defined by the following properties. So P of n t1 t2 equals to k is equal to e raised to power minus lambda t to the power k upon k factorial. And if the intervals t1 t2 and t3 t4 are non-overlapping, then n t1 t2 and n t3 t4 are independent, and at a time moment t there is no more a one Poisson point. So using the points ti, we form the stochastic process xt equals to n0 to t, and we need to find for the first part the expected value of xt, and for the second part r of t1 t2. So starting off with the first part, so we know that p of x equal to k is given by e raised to power minus lambda to the power k upon k factorial, and we know that for probability density function, the summation of this from k equals to 0 to infinity will be 1. We can move e raised to power minus lambda to the other side, since it is not dependent on k, and then we'll differentiate both sides with respect to lambda. So we'll get k lambda to the power k minus 1 upon k factorial, and this will be raised to power lambda. We can multiply both sides by lambda, so we can get summation k lambda to the power k upon k factorial equals to e raised to power lambda times lambda. Now we can move back e raised to power lambda to the left side, so it will be e raised to power minus lambda, and we know that this term is the expected value of x. So we have found the expected value as lambda. Now for sigma square, we know that it is the expected value of x minus eta to the square, which can be written as expected value of x square minus eta square, and eta square we have already calculated while in the previous part. So this will become expected value of x square minus lambda square. We are just substituting the value, and so now we can actually, to find the expected value of x square, we can use the previous equation, which is this one. So we can use this equation, and we can take differentiation of this on both sides with respect to lambda. So what we get is, on the left side we can see it will be k square lambda to the power k minus 1 upon k factorial, and on the right side, if we take the differentiation of lambda e raised to power lambda, we'll get e raised to power lambda 1 plus lambda, basically this term. Now we can again multiply, we can take this term e raised to power lambda to the other side, so it will be e raised to power minus lambda, and if we see this term is equal to e raised to power this term is equal to expected value of x square, so we can plug in the value in the above equation. So we get the variance as 1 plus lambda times lambda minus lambda square, which is again lambda. So we know now that from these above results that expected value of xt is equal to lambda times t. Similarly, expected value of x squared t is equal to 1 plus lambda t times lambda t, and the variance of t is equal to lambda t. So now let's move on to the second part. we have to find r of t1 t2. Now we'll consider two cases. For the first case, we will take t2 is greater than equal to t1. So we can see that x, so we know that x t1 equals to x t1 minus x0, and x t2 minus x t1 are independent. So using this, we can write r t1 t2, which is basically expected value of x t1 times x t2, as basically we are rewriting the second term, so it will be expected value of x t1 times, now the second term can be written as x t2 minus x t1 plus x t1, so we are adding and subtracting x t1, which won't make any difference, but uh, we know that x t2 minus x t1 are independent, so we can use this and split the term as follows. So this will become expected value of x t1 times expected value of x t2 minus x t1, plus the second term will be expected value of x t1 x square t1, and so this can be written as lambda t1, and this will be lambda t2 minus lambda t1, and this also we have calculated previously, which is, we see it is 1 plus lambda t times lambda t, so here we have t1, so 1 plus lambda t1 times lambda t1. On solving we'll get lambda t1 plus lambda t1 t2. Now following the same for the case when t1 is greater than equal to t2, we'll get r t1 t2 as lambda t2 plus lambda t1 t2. So we know that from the above two that in both the cases we have lambda whatever is the minimum of t1 t2. So in this case minimum is t2, so we have the t2 term. In the previous case it was t1 less than equal to t2, so t1 is minimum, so we have t1 term. So basically lambda times minimum of t1 t2 plus lambda t1 t2. So that is all for question 8 of homework 7.